We can take one more examples on calculation on entities. Find the number of moles of number of moles in 5.6 liter ammonia at 1 atm pressure in 273 Kelvin. Obviously 1 atm in 273 Kelvin is the condition of NTP. So we can directly calculate the number of moles of ammonia, which is 5.6 divided by 22.4 liter. If other data is given, except other data of pressure and temperature is given, then we can use the PV equal to nRT equation. So the correct answer will be 1 by 4. Now mass of 11.2 liter CH4 at 1 atm pressure in 273 Kelvin is to be calculated. Obviously 1 atm and 273 Kelvin is the condition of NTP, which is normal temperature and pressure. So to calculate the mass of 11.2 liter of CH4, first we will calculate the number of moles. First we will calculate the number of moles, that will be equal to 11.2 divided by 22.4. So this will give 1 by 2 moles of CH4. Now it is to be converted into mass. So we will multiply by this by 16. Right? We will multiply by this 16. So this will get 8 gram. Now in the second question, we want to calculate volume of 128 gram of SO2 at 1 bar pressure in 273 Kelvin. So 128 gram SO2 we can calculate because this is the condition of NTP also. Actually this is the condition of STP, which is standard temperature and pressure, because 1 atm pressure is we take at NTP and 1 bar pressure at STP. Though the volume occupied by 1 mole of an ideal gas at STP condition is actually 22.7 liter and at NTP 22.4 liter, but for the numerical calculation we can take it 22.4 liter. So first at all, 128 gram of SO2 will be converted into the number of moles, that will be 128 divided by molar mass of SO2, which is 64. Now volume is to be calculated, so this will be multiplied by 22.4 liter to calculate the required result. Now we wish to calculate 0.2 mole of CD4, volume of CD4 at 1 atm and 298 Kelvin. Now very obvious the temperature is given different, it is not condition of NTP. So we will use PV equal to nRT to calculate the volume, which will be V equal to number of moles is 0.2 and R is 0.0821 and temperature is 298 Kelvin. Now divided by the pressure is 1 atm. We can solve this equation to calculate the volume of CD4 at 1 atm and 298 Kelvin. Next question is given that 22 gram of ideal gas occupies 11.2 liter at 1 atm and 273. So obviously NTP condition is given. Now we want to find the gases possible. So definitely to find the gases we must calculate the molar mass. So we can form the two equation. First at all, we can use this data, which is 22 gram of ideal gas. We can find the number of moles, that will be 22 upon capital M, which is the molecular mass. Now 11.2 liter we can take this, so we can frame the one equation from this data of moles, which is 11.2 divided by 22.4. What I said, for this question I write two equations for the moles, from first from this data and second from this data. This is equal to 1 by 2. Now we can put equal to equation 1 and equation 2, which will give molecular mass is equals to 44. Now we can calculate the molecular mass of each, and definitely the B and D option will be correct for this. So this is the question that is asked in IIT for in more than one correct. In the question number 5, if from 3 moles of Epsom salt, which is MgSO4.7H2O, all the oxygen atoms are removed and converted into ozone, then find the gram molecules and molecules of ozone. So this question can be considered as an integer type question because it is required to calculate gram molecules, which is amount of substance, which is moles, while this is molecules, which is entity. So first we consider 1 mole of MgSO4. So 1 mole of MgSO4 contains 1 mole of MgSO4.7H2 contains obviously 11 gram atoms of oxygen. So 3 moles of MgSO4 dot 7 H2O contains 33 gram atoms of oxygen. So from 33 gram atom of oxygen, definitely 11 gram molecules of ozone will be formed, right? Because one molecule of ozone contains 3 atoms of oxygen, so 33 gram atoms will be converted into 11 gram molecules of ozone. So for integer type questions, for the first part, the answer we can write as 0011. And now to calculate the molecules of ozone, we can multiply this by Avogadro's number. So for the part 2, the number of molecules will be equal to 11 Na. Thank you very much.